Welcome back. This is video number 2 about microscopy. Microscopes are pretty important for biology, so we're going to spend a couple of videos looking at them. Cells are studied using microscopes, and microscopes let us see things that we can't see with the naked eye. The naked eye means, like my eyes are now, I've taken my glasses off, so it's like my eye is naked. So we can use microscopes to see things that are too small to see with our eyes. The microscopy techniques that we have developed over the years change as technology improves and as our knowledge has improved. So the very first microscope was a bit more like a telescope, really. It was just a tube with 2 lenses in. Then this is the kind that we use in school. You should recognize this as a light microscope, all the way up to what's called an electron microscope. And these are like the really high-tech ones, get really, really good images from. So if we compare a light microscope with an electron microscope, light microscopes use light and lenses to form an image of a specimen and magnify it. Magnify means they make it look bigger than it really is. Light microscopes will allow us to see whole cells and large subcellular structures like the nucleus. Electron microscopes use electrons instead of light to form an image. They have a much higher magnification than a light microscope. They also have a higher resolution. Resolution is the ability to distinguish between 2 points. So a higher resolution will give a sharper image. Electron microscopes let us see much smaller structures in more detail. So we can see the internal structures of mitochondria and chloroplasts, and they will let us see even tinier things like ribosomes and plasmids. You need to be able to use the formula for magnification. You can calculate magnification of an image using this formula. Magnification equals image size divided by the real size. The image size and the real size should have the same units, and if they don't, you'll need to convert them first so that they match. If you want to work out the image size or the real size of an object, you need to rearrange this equation. So I'll give you a little practice question. You can pause the video now and try and work out the answer. If you think you might need a little bit more guidance, then you can play the video for another minute or so, and that will give you some guidance, and pause it a bit later. So the question: a specimen is 50 micrometers wide. Calculate the width of the image of the specimen under magnification times 100. Give your answer in millimeters. So you're trying to calculate the image size. So you will need to rearrange this equation. Pause the video now. Write your answer in the comment section below. So if you need a little bit more guidance, the question is up there at the top. First step is to rearrange the formula. Fill in the values that you know. Remember the units in your answer, making sure that they match. Convert the units. So it's asking you to convert from micrometers into millimeters. So if you remember, we've used triangles like this before, where you put your hand over the thing that you want to find, and then you use the bottom half of the equation to work out what you need. So if you want to pause the video now and have a go at the question and then put your answer in the comments below, do that now. Okay, so covering up the image size tells us that it's the actual size times the magnification is what the equation will be. So if we use the numbers from the question, the actual size was 50 micrometers and the magnification was 100. So 50 times 100 gives you 5,000 micrometers. But it asks us in the question to give our answer in millimeters. So 1 micrometer is 1,000th of a millimeter. So we need to divide our 5,000 by 1,000 to get it back into millimeters. That would be 5 millimeters. Give yourself a pat on the back if you got that right. Okay, you need to know how to work with numbers in standard form as well, because microscopes can see such tiny objects. Sometimes it's useful to write numbers in standard form. This is where you change very big or very small numbers with lots of zeros into something that's more manageable. So we're going to use this example. 270,000 in standard form would be written like this: 2.7 times 10 to the power 5. So to do this, you just need to move the decimal place left or right, and the number of decimal places, or the number of times the decimal places move, is the power of 10 that you will get. And if you move to the left, then you will get a positive power. And if you move to the right, you will get a negative power. So if I talk you through this example, 270,000.0, the decimal place would be there. How many times do you have to bounce the decimal place to have a number between 1 and 10 at the front? So if you look at my bounces, 1, 2, 3, 4, 5, that's where the power of 5 came from. And that's how we would work it out. So see if you can work this one out. Pause the video. A mitochondria is 0.0025 millimeters long. Can you write this in standard form? So pause the video, have a go, comment down below. Okay, so if we look at this example, I've had to bounce the decimal place to the right 1, 2, 3 times to get a number between 1 and 10 in front of my decimal place. So the answer would be 2.5 times 10 to the power 3. So this is the end of the second video. Hopefully you will continue on to the third video, more about microscopes and a little bit of information about the required practical. And I will see you in that video.